Hi everyone. This video we're going to talk about open method. So you have seen closed method before, which is the bisection method and the false position method, in which the roots must be in the bracket of XL and XU. But in this case, you only require a single starting value of X or 2. It can be either 1 or 2. It's different, like in the bracketing methods, you need 2 starting values. But for the open method, you can either work with 1 or 2 starting values that do not necessarily bracket the root. Meaning your XU and your XL, it doesn't have to be bracketing the root. So in the closed method, the root must always be in the bracket of XU and XL. But for the open method, the XR can actually be located outside the bracket of XU and XL. So this open method, it is sometimes diverge or move away after several computations, and when it converge, it will be faster than bracketing method. So there are 3 methods that you're going to use, which is simple fixed point iteration, Newton-Raphson, and the second method. Let's look at the first one, which is a simple fixed point iteration. So this method is done by rearranging the function f(x) equals to 0 so that x is on the left-hand side of the equation. So let's say you have, for example, you are given with this equation. You need to rearrange the function f(x) so that x is on the left-hand side. So it has to be like this. X equals to something. Then only you can start calculating. So in this case, you can rearrange. You can select your x here. So what you can do is negative 2x equals to negative x squared minus 3. So this and this you bring to the right hand side. And then actually you can change this all to positive. So this is like x equals to x squared plus 3 divided by 2. So you have this equation to start with in order for you to use simple fixed point iteration. The rule is very simple. You just need to make sure that the left hand side you only have a single x, not x squared, not x over 2, not 2x over 3, no. Okay, just a single x. So another example is you are given as sine x equals to 0. So how are you going to do this? You can just add x to both sides. So here, x equals to sine x plus x. But you can only do this if there is no direct x that you can work with. Okay, there is no like x squared or 2x. It's just sine x and everything. So to simplify things, you can add both x. You can add x at both sides. Okay, these provide a formula to predict a new value of x as a function of an old value of x. Now that you got your equation, x equals to gx, what you want to do is you predict a new value of x based on an old value of x. Alright, now given an initial guess at the root xi, the equation can be used to compute a new estimate as expressed by the iterative formula. So this is what it means just now. You are actually calculating a new x based on an old x. Because xi is an old x, xi plus 1 is the new x. Okay? You calculate a new value of x based on an old value of x. You will see later through the example. Okay, so this is very important. The correct iterative function, meaning this one, can be determined as follows. G prime x must be less than 1. So what does it mean by this? Sometimes when you come up with this function or equation, it might not be correct. It can diverge. So that's why it is very important for you to double check using this formula in which g prime x, it has to be less than 1. If it's more than 1, then you need to find another equation. And then the approximate error for this equation can be determined using the error estimator. This thing here, it should be right here, like that. Okay, so EA is this is just an approximation. Xi plus 1, your current value, current answer minus previous answer divided by current answer times 100%. Okay, so this is the procedure of a simple fixed point iteration. First of all, you need to state the initial guess. Don't worry about this. Usually your initial guess will be given, and again your stopping criterion also will be given. And then you need to rearrange the function. So now you need to do this yourself, in which you need to rearrange again the function so that a single x is on the left hand side. So you just need to make sure at the left hand side there is only a single x, not x squared, not 2x, not x over 2, alright? And then equals to, this can be anything. And then you need to check whether your function here is okay to use or not, whether it will give you a converging result. Because sometimes the function that you have just created, it will give you a diverging answer. So how to know, especially when you're in the equation when your fx have a lot of x, you have 2x, you have x squared, either you want to select your x squared or your 2x, you need to know which one. So that's why this is important. You need to check whether your g prime x, whether you're this one, but the derivative, is it less than 1? So let's say your x here, this one, is equals to 2x squared plus 3x. Okay, plus 3x plus 4. Alright, so how to check whether g prime x is less than 1 or not? So this one, your gx here, this is your gx, you need to take the first derivative. Okay, so this one, g prime x is 4x plus 3. Okay, so what you need to do is just substitute your initial guess. Let's say your initial guess is 0. Okay, let's say your initial guess is 0 into this equation. So 4, 0 plus 3, and you will get a 3. You will get a positive answer, which is more than 1. And this is not good. Okay, this is not good. So you cannot use this formula. You need to rearrange back your x into another way, into another formula. And then next is you need to determine your xi plus 1 from your final function. So this is what I mean by calculating a new value of I based on an old value of I. And then next, your EA. EA is just the current xi minus the previous xi divided by your current xi times 100%. If your EA is more than your ES, you need to repeat step 4.